Hi there, this is video 4.3, solving quadratic equations by factoring. Okay, our concepts here are we're going to write quadratic equations in standard form, and we're going to solve quadratic equations by factoring. Now, we've already solved them by graphing. Now we're going to do it algebraically. So let's look at our two vocabulary words. Factored form. Factored form is just 0 equals, whoopsie. So it's 0 equals a times x minus p times x minus q, where p and q are going to be your roots, your zeros, x-intercepts, and solutions. So you notice, so if we say p is 2 and q is 4, we can go back and put them back into our equation. We're just going to ignore a for now and do x minus 2 times x minus 4. Now we have our two factors, and we can put this into a standard form equation. Now, what if this was negative? So remember, it's x minus negative 2, which becomes x plus 2. So don't forget how to do sign numbers. So that is factored form. Now, we can take factored form, so let's just take x plus 2, or actually, let's take x plus 1 times x plus 2. So we had our roots, we put it in factored form. And now we want to put this in standard form. Remember, standard form is going to be in the form of ax squared plus bx plus c. So now in order to do this, we're going to use the FOIL method, which you should already learn, which is first times first, outer times outer, inner times inner, and last times last. So let's do this together. So first times first is x squared. Outer times outer is plus 2x. Inner plus inner is plus x. And last times last is plus 2. When you do in this order, you'll notice the two inner terms are like terms. So you combine those based on their signs. And then now we have an equation in standard form. So let's go through the examples. We're not going to spend a lot of time. Because most of this chapter is factoring. The only difference is we're factoring so we can solve for our zeros, our roots, our solutions, and our x-intercepts. All right, so let's look at example 1. It says, write a quadratic equation in standard form with negative 1/3 and 6 as its roots. So we're saying p, it doesn't matter which one this was, negative 1/3, and q is 6 because those are our roots. Now we put it in our format, x minus negative 1/3 times x minus 6. This becomes x plus 1/3, and don't let the fraction scare you. And then we simply are going to do FOIL. We're going to FOIL this, and we get x squared plus 1/3 x minus 2x. Hold on, I got this wrong. First time first, outer times outer. I did this backwards. Plus 1/3 x minus 6x, minus 2. And when you combine these, we get x squared minus 17/3 x minus 2. You got to remember how to do fractions. So there's our equation in standard form. So pause this, do guided practice 1, which is going to be the same thing. Now, let's look at the zero property. This becomes important here. Zero product property. What it says, if you have any real numbers if you have a and b that are real numbers, and if a times b equals 0, then either a or b or both have to both equal to 0, because anything times 0 is 0. So for example, if you have x plus 3 times x minus 5 equals 0, then you can say x plus 3 equals 0 or x minus 5 equals 0. And then we can solve for x. And that's how we find the roots. Okay, so basically that's what we're using when we're solving. So we have a quadratic equation. So we're going to look at this first one, this first example. So we have a quadratic equation. So 16x squared plus 8x equals 0. All right, so it's got to be equal to 0. We have a quadratic. We're missing the constant term, but that's okay. So we're going to factor this first, and then we're going to set each one equal to 0 to find the roots. The solutions, x-intercept, same difference. Because we're using the zero product property. Now, no matter what, you always want to see if you have a GCF, which we do. We can factor out an 8 and an x from both of these. So remember, when we're factoring out, we're really dividing by that value. So this becomes 2x plus 1, not 0. Anything divided by itself is 1, not 0. I know we think cancel in our head. Cancel means go away. It does not mean go away. So then now we've got two factors. Can't we set them each equal to 0? So I'm not going to do the algebra here. So this one and this one is 0, not undefined, because you can do 0 divided by. So our two solutions, or our roots, or where the graph crosses, is at -1/2 and x equals 0. And we know it opens up. The vertex is somewhere right here, so it's a really skinny graph, and it's going to do something like this. Okay, so pause the video, do guided practice 2A, 2B, and 2C. Now let's look at some special cases. So we have a perfect square, what's called a perfect square trinomial, and differences of square. Here we're going to be on example 3. Now, I don't know why the guided practices don't really go along with this, but we're just going to go with it. So again, let's look at first to see, do they have GCFs? No, they don't. You can't factor out a GCF. We'll come back to this one. So what they want us to learn here is what a perfect square trinomial. A perfect square trinomial is when the first term, and we're not going to say quadratic term, which that's what the first term is called, because this also applies to polynomials, and we'll see it later down the road when we're doing polynomials, which could have powers of 4, 6, 8, 5, whatever. So the first term is a perfect square, and the third term is a perfect square. If those two are perfect squares, and you take the square root of the first one, so let's just look at this problem. So we have x squared plus 16x plus 64 equals 0. Now, we said this first one's a perfect square, and this is a perfect square, the third term. So we take the square root of each one, times them towards each other, and then times 2, and we get 16x. That will be the middle term. If this is the case, then we have a perfect square trinomial. And how do we factor them? They have their special cases. So because we know it's a perfect square trinomial, we take the square root of the first, the square root of second, and we put a plus sign. Oops, sorry. Rewrite this. And then we square it. And that's how you factor it. And if you don't believe me, you can remember this is the same thing as saying x plus 8 times x plus 8. And how do we check our factoring? We FOIL them back to make sure we got the right answer. And if you do, you will get this. So now we just take what? The square root of both sides. So x plus 8 equals 0, u minus 8 minus 8. So we only have one solution, which tells us, and you need to know this because I'm going to ask you to interpret the graphs and solutions. So we have one solution, so we know that the vertex lies on the x-axis, and we know it's opening up, and it has a minimum on the x-axis. Okay, let's look at the second case, which is x squared equals 64. So this one can be solved two ways, and I'm going to show you the first way. So I'm going to use algebra to rewrite this, and that's all I'm using. I'm not changing it. I'm just rewriting it using algebra. So when we have a special case called the difference of perfect squares, that means this is a perfect square, this is a perfect square, and the sign in between is difference, which is minus, not plus, minus, then this is a special case. So to factor this, you take the square root of the first, the square root of second, and you write this 2 times, kind of like we did for perfect square trinomials. However, one's a plus and one's a minus. And if you FOIL this, you'll notice that the two OI of FOIL are going to be opposites. This is going to be 8x and minus 8x, and they end up 0, which we don't have a middle term here. We don't have a linear term. We only have a quadratic and a constant. So now, how do we solve this? We say x plus 8 equals 0, and x minus 8 equals 0, so x equal negative 8, and x equal 8. Okay, so there's your solutions. The other way to solve this is to say, if you have x squared equals 64 and you don't have a linear term, well then you can just take the square root of both sides, so this becomes x. Now remember, when you're solving the equation and taking the square root, you're going to have two solutions. So I'm going to put plus or minus. Square root of this is 8. So I have x equal positive 8 and x equal negative 8. Isn't that what I had here? I got the same way, just using two different methods. So always look for GCFs first, and for whatever reason, the guided practices don't really match the perfect square trinomials. Just one of them does, and the rest you have to kind of factor. So just factor them, do the problems. It's 3A, 3B, and 3C. So now we're going to just plain factor, which we've already had a whole lesson on factoring, so we're not going to spend a lot of time. So remember, when A is plus or minus 1, we use this method. And when A is not equal to plus or minus 1, we use this method. We use this chart, but we're going to use either grouping, box method, or the California method. The book teaches you grouping. You're more than welcome to use that. Use whatever method works for you. So let's just go straight into factoring. So example 4. So we have x squared plus 9x plus 20. Well, A is positive 1, so we're going to use this method. So we're going to go write our little box, and C goes here, and B goes here. So what two factors of 20 have a sum of 9? Well, 4 and 5. So we're going to do this. The product of 4 times 5 equal positive 20, yes. Does the sum equal positive 9? Yes. So our factors are x plus 4 times x plus 5 equals 0. So now we're going to set each one equal to 0 and solve. So our solutions are x equal negative 4 and x equal negative 5. So this is where, and we can put it in our calculator, we can graph it, we can make a table, and we're going to see that this is where the graph crosses the x-axis at negative 4 and negative 5. Now let's look at B. B, you have 6y squared minus 23y plus 20 equals 0. So here I'm going to use this method because I have A is not equal to 1. So 6 times 20 is 120, and then negative 23. So I need to find two factors that equal 120, whose sum equals negative 23. Well, I know that this is positive, so I know that they're either both going to be positive or both negative. However, if they're both positive, the sum is going to be positive, and I need the sum to be negative. So I know that they're going to be negatives. So if we take negative 8 and negative 15, the product equals positive 120, and the sum equals negative 23. So I'm going to use the California method. So x minus 8 times x minus 15. And I need to divide by A. Okay, so this reduces to x minus 4/3. And this reduces to x minus 5/2. Now remember, you cannot have, when you're doing a California method, if they're not an integer, the quotient's not an integer, what happens to this? It moves to the coefficient. So this becomes 3x minus 4 times 2x minus 5. Now I've factored it. Now I can set them both equal to 0 and solve. So x equal 5/2 is one solution, and x equal 4/3 is my second solution. So pause the video, do the factoring of guided practice 4A, B, C, and D, and they're going to be fractions, so no longer be pretty numbers. So you need to just know how to do fractions. And always start off with, do I have a GCF in all three terms, and factor that first. So let's look at the real world example here. This is going to be important because you need to be able to interpret and understand what's going on. So it says example 5. The height of a javelin in feet is modeled by this equation, h of t equals negative 16t squared plus 79t plus 15, where t is the time in seconds after the javelin is thrown. How long is it in the air? Well, first of all, we know it's a physics problem. It's a javelin. We know it's going to go up and down because a is negative, so we know it's going to do something like this. Okay, where this is the feet, the height, and this is the time in seconds. Okay, so we want to know how long was it in the air. We don't know, did it come here? Did it start over here? We don't know, but I'm just kind of sketching. I know it's going to come back down over here in the positive. So I'm trying to find the time the javelin actually spent in the air. Okay, so I need to find the second zero, right? I might have another zero here. And now if my zero is anywhere over here, then I'm just going to find the difference between these two. Okay, so you have to understand what's going on. So I need to find both zeros and find out where they are on the graph. So I'm going to take my equation, negative 16t squared plus 79t plus 5. So I have to factor. A is not 1, so I'm going to make my little box, and I get negative 80 and 79. Well, I know this is negative, so they're going to be opposite signs. So I'm going to go with 80 and negative 1. Well, the product equals negative 80, but does the sum equal positive 79? Yes, it does. So I have x minus 80 times x minus 1. I'm going to divide by negative 16 because that's a, and I'm going to get x plus, I'm sorry, this was plus. So I'm going to get x minus 5 times x plus 16, 1 over 16. So remember, this has to go to the coefficient because I'm using California method. X plus 1 times x minus 5. And I solve, I get x equal 5, and I get x equal negative 1/16. So somewhere over here is where the other zero is. Now, remember, I can't have a negative time, so I need this time over here, so it would be fair to say that the javelin is in the air for 5 seconds. So I disregard this because I can't have a negative 1/16 time, correct? And then it goes up probably somewhere here. So the time is 5 seconds. So this is the end of the video. Do the last guided practice 5, and we'll see you in class.